Welcome back to the series, How to Help Your Kid Master Addition and Subtraction of Fractions the First Time. We'll be looking at changing both denominators again, but we'll be taking a different view of it. Jessica mixed 3/4 cup of cranberry juice and 2/3 cup of apple juice to make cran apple juice. How many total cups of juice did she make? We're starting out with our 3/4 plus our 2/3, and we know that our estimate is going to be somewhere between 1 and I'd say 1.5 at this time, around 1.5 cups. And this time we're going to be using an area model to solve these. And I wanted to do this to show the different ways that you can think through these types of problems with kids to help them to see that they will use the model that best makes sense to them. When you are very intentional about choosing the fractions that students will model, the simpler fractions where they can see those relationships easily, then they'll be able to apply that knowledge when fractions become more complex, that addition becomes more complex, and they aren't able to actually create a model for them. So they have this to fall back on. So I have the 3/4 of one rectangle that I've drawn, and I partitioned it vertically and shaded in 3/4 that way. And the other rectangle is about the same size as the first. You want to make sure that is done for sure because you want the same size hole. And those are partitioned horizontally and shaded in so that the kids can see when they are making those common denominators, making those the sizes of those pieces the same size. It's easier to see that they have made them the same size. So they get that common denominator, making those equivalent fractions. So since in 3/4 I have partitioned it vertically, now I'm going to come back across and partition it horizontally in 2/3. And for the 2/3, I'm coming back and I'm going to partition it vertically, making fourths. And so, of course, I've made twelfths. So thirds and fourths make twelfths. So 3/4 times 3/3 gives me 9/12. 2/3 times 4/4 gives me 8/12. And when I add those two together, I get 9/12 plus 8/12. And those two together make 17/12. And of course, you'll have kids who need to see how their estimation, how their solution is reasonable to compare to the estimation. We know that the estimate was between 1 and 2, and I think it's going to be closer to 1.5. So this helps to see that. And they can draw it all out so that they can see that in two rectangles. So they shade in that first rectangle, 9/12. And then in that same rectangle, they're going to start shading in their 8/12. So 17/12 is equal to 12/12 plus 5/12, and they get 1 cup and 5/12 of another cup, which is about 1.5 cups. This problem can also be solved using the previous model that we used by using the fraction representations in the strip or the fraction bar, where in that first fraction in the top part we shaded in fourths, and in the bottom we shaded in thirds. And each third will be partitioned into fourths. And beginning in the middle, especially when you're partitioning fourths, always begin with dividing it in half first. That's a big tip for kids. And then with the fourths, to partition that each fourth into thirds. So that becomes 3/4 times 3/3 is 9/12. And so you get the same thing, but this is just a different way of looking at it. If you found this video helpful, don't forget to get your copy of Fractions Made Easy, a helpful resource that provides a list of support videos with pictorial representations to help you get your kids to where you want them to be.